this video, we're looking at our function notation again, but we're going to be working with multiple functions and putting them together and solving them. So the learning goal for this video is that I can solve questions in function notation. This is part 2, almost a continuation from the last video, which is why we're starting at 3. So in this video, we are given 3 functions. We've got up here an f of x, which is defined as x squared minus x. We have got a g of x, which is this radical looking thing over here with x plus 4 underneath the square root sign. And we have got h of x equals 4x minus 12. So now this is actually starting with one that is kind of like the last video. Find x if h of x equals 10. So if my h of x, which is like my y, is 10, and I want to find what value of x gives me that, I sub in my 10 for my h of x, and now I need to get x all by itself. So if I plus 12 on this side, I want to add 12 to that side. So this side will end up being 22. This side, the 12 and the plus 12 cancel each other out. I'm just left with 4x. Now, I don't know what x is because there's that 4 in front. I divide off that 4, and this isn't going to work out perfectly, but 22 divided by 4 is 5.5 or 5.5. So when h of x is 10, x would be 5.5 or 5.5. Now, we didn't incorporate f of x or g of x into this one. This question was only asking for h of x. But we could get another question. Now, there could be questions where we sub in for x to figure out what f of x when x is 2 minus h of x at 1 would equal. This one is saying, what is x when f of x equals h of x? So when f of x up here is equal to h of x. So what I want to do is I want to set these two things equal to each other. X squared minus x. What is x when these two are equal? Now this is going to be quadratic because we've got a squared here. So it's almost like we're finding the point of intersection of these two things. What is it what are the values where these intersect? So I've got to get everything to one side. So I'm going to add x, and add x to bring that x over to this side. So I've got x squared equals 5x minus 12. And now I will bring this x squared over to the other side. So I've got 0 here. That becomes a minus x squared plus 5x minus 12. Okay, so now we've got to think, actually, this is a complex trinomial, so I'm going to multiply everything here by minus 1. So it's a simple trinomial, so I can look for factors easier. So I can see how I can factor this in. So I'm looking for two numbers that multiply to give me 12 and add to give me minus 5. Okay, I can't seem to think of any off the top of my head. So, when we can't factor, we want to use our quadratic formula. Minus b plus or minus the square root of b squared minus 4ac all over 2a. So our a is 1, our b is minus 5, and our c is 12. So if we sub into our formula here, we've got a minus minus 5, so we've got a plus 5, plus or minus the square root of minus 5 squared minus 4 times 1 times c, which is 12. I'll extend my root over here, all over 2 times 1. Okay, so x is equal to 5 plus or minus the square root of minus 5 squared is 25. Minus 4 times 12 is 48. And I think we're going to stop here. I'm not sure if anyone else sees it. Is 2. If I look underneath this square root sign, minus 25 minus, or sorry, 25 minus 48 is going to be minus 23, and we can't take the square root of a negative number. So what this is telling me is that there is no place where these two things intersect. So there is no place where these two things are equal. So therefore there is no x. That will make f of x equal to h of x. And writing on this pad is a little bit tricky, so I won't fill all that in. But if we look at our Desmos site, and we graph each of these, because these are functions, right? So if we were to graph, here we go, we're graphing here f of x equals x squared minus x, and it looks like this. And then on the next line here, we're going to graph h of x, which is 4x minus 12. We can see that these two things do not cross, so these two things are not equal. Okay, so let's go back, let's try another one that we might get. We've still got these same functions, f of x, g of x, and h of x. Now this one's a little bit interesting. F of h of x. So what this is saying is we've got h of x equals this, and we want to sub that into f of x. So I'm going to take this value here, and this is going to be my new x in f of x. Ooh, okay, there's lots going on here. Let's sub this in and see what it looks like. So instead of x squared, I'm going to sub in 4x minus 12. When we sub in, we should sub in brackets 4x minus 12 squared. And now for all instances of x, even this one down here, I'm going to sub in 4x minus 12. Okay. We got to make sure we don't just bring this squared down here. A lot of people do that. We need to write out the bracket twice. and FOIL that in, or math rainbows, or whatever it was we were taught that that was called. Minus 12, there we go. So we need to multiply this here, we need to multiply this here, we need to multiply this and this. So when we just bring that squared in, we end up missing the middle term. So we get here 4x times 4x is 16 x squared. We get 4x times minus 12 is minus 48x, minus another 48x, and 12 times 12 is 144. And then over here we need to also remember to bring this minus into the brackets here. So we've got a minus another 4x and then plus 12. Okay, so there is only one x squared term. There are 1, 2, 3 x terms, and then 2 numbers, so we'll put this all together on the next line here. We've got 16 x squared minus 48 minus 48 minus 4 is going to be minus 100 x, and 144 plus 12 is a plus 156. So f of h of x is equal to 16x squared minus 100x plus 156. And this is dealing with multiple functions. That g of x in all these past couple questions ended up just being almost a diversion to try and throw us off. We didn't actually end up using g of x at all for anything, but potentially we could. Perhaps the next question would be g of f of x or something like that, where this could get involved.